Hello guys, welcome back to another video of becoming a code expert. In this video, we will be looking about Bitwise operators. If you're a beginner and if you got really bored by studying the concept theoretically, then this video is for you. Before getting into the video, subscribe my channel so that you don't miss any further updates. Now let's get into the video. So basically what does Bitwise operators means? They perform bitwise operations on integers. So what happens here is when an integer number is given as the input, this will be converted to binary and the operations will be done, that is the bitwise operations. And after the operator is being performed, this will again be converted into decimal number. So first I'll teach you how to convert an integer into binary. For example, I'm having a number as 10. So to convert this into binary, I'll be dividing it by 2. So 10 divided by 2 will give you 5 and the remainder obtained is 0. And again 5 divided by 2 will give you 2 and the remainder will be 1. And again 2 divided by 2 will give you 1 and the remainder will be 0. So to obtain the binary number of this number, I'll be moving from the end and to the top, and the binary number will be 1 0 1 0. And now to convert this again to decimal number, what we do is this binary will be represented as 1010 to the base 2. This 2 indicates that it is a binary number, and to convert this into decimal again there is a table. I'll write from the last. We'll write 1 first, and 1 into 2 will give you 2, 2 into 2 will give you 4, 4 into 2 will give you 8, 8 2s are 16, 16 2s are 32, 32 2s are 64, and 64 2s are 128. So I'll be writing this 1010 from the last, that is 0 1 0 1. So I'll be checking wherever there is 1. So here I'm having a 1 and here I'm having a 1. So wherever I'm having the 1, I'm going to add those numbers, that is 8 plus 2. This will give you 10. This is how we find the binary number, and then we convert it into decimal. And now let's move on to the bitwise operations. In bitwise operators there are 6 operators. They are, the first one is AND. We call this as bitwise AND. This is represented as X and Y. And the next one is OR. It is bitwise OR and it is represented as X or Y. And the next one is NOT. That is bitwise NOT. This is represented as NOT X. As I have discussed previously in the logical operators, there is only one variable for this, that is X, and the next one is XOR. This is called bitwise XOR. And it will be represented as X XOR Y. And the next one is bitwise right shift, and here X is shifted to the right, so it is X and right shift. And the next one is bitwise left shift, and here X will be shifted to the left, so it is X and left shift symbol. And now I'll teach you how each operation is done and the truth table. First I'll teach it for bitwise AND. So basically in a binary number there will be only zeros and ones. So for 0 and 0 the output will be 0. For 0 and 1 the output will be 0. For 1 and 0 the output will be 0, and for 1 and 1 the output will be 1. And same way for bitwise OR. For 0 or 0, the output will be 0. For 0 or 1, the output will be 1. For 1 or 0, the output will be 1. And for 1 or 1, the output will be 1. And the next one is for XOR. In XOR, whenever the inputs are similar, the output will be 0. And whenever the inputs are different, the output will be 1. So for 0 XOR 0, the output will be 0. For 0 XOR 1, the output will be 1. For 1 XOR 0, the output will be 1. And for 1 XOR 1, the output will be 0. And the next one is for Bitwise NOT. Here we are having only one input in each of these. 0 will give you 1 and 1 will give you 0. Now I'll explain the operations of all of these. The first, let us see for Bitwise AND. For example, I'm taking a number 7 and 0. First, I will have to convert this 7 to binary. On converting 7 to binary, we get 1, 1, 1. And on converting 0 to binary, it will be 0, 0, 0. So 1 and 0 will give you 0. 1 and 0 will give you 0. 1 and 0 will give you 0. So this again, on converting it to decimal, we get it as 0. And to represent decimal, we cover this inside a parenthesis and write 10 as the base. The next one is for Bitwise OR. I'll write Bitwise OR for 7 or 1. So first I'll convert the 7 to binary. This will be 1, 1, 1. And on converting 1 to binary, this will be 0, 0 and 1. So here 1 or 1 will give you 1, 1 or 0 will give you 1, and 1 or 0 will give you 1 again. This is in binary. And on converting this back to decimal, it will be 7 as a decimal. The next one is Bitwise XOR operation. First I'll take a number 7 XOR 4. So 7 on converting it to decimal, I get 1, 1, 1. And 4 on converting it to decimal, I get 1, 0, 0. So 1 XOR 0 will give you 1. 1 XOR 0 is 1. And 1 XOR 1 is 0. So this on converting back to decimal, I get 3. And the next one is Bitwise NOT. I'll do it just for 4. So 4 on converting to binary, I get 1, 0, 0. And doing NOT operation, 0, not 0 is 1, not 0 is 1, and not 1 is 0. So 0, 1, 1 will give me 3 as the decimal. Now let's do a code for this. First I'll print for Bitwise AND, and then I'll do 7 and 4. The next is Bitwise OR. It will be 7 or 4. The next one is Bitwise NOT. This is the NOT symbol and not 4. And the next one is for XOR. Bitwise XOR. It will give you 7. This is the XOR operator, and 4. And now I'll run this code. Okay, so on Bitwise AND I get 4. On Bitwise OR it is 7. For NOT I got 5. And for XOR it is 3. Thanks for watching this video. If you have any doubts, you can ask me in the comment section. And in the next video, I'll be teaching about the bitwise right shift and left shift operations. I'll see you in the next video. Thank you.